In this video, we'll learn about storage I/O control and how it can be used to prioritize storage traffic for certain virtual machines. So what storage I/O control does is it provides prioritization of storage IOPS. Right? And just think of storage IOPS as either reads or writes. Right? They're any kind of storage command that's traveling over a network. And what storage I/O control does is it uses shares, reservations, and limits to control and prioritize certain VMs over others. It'll monitor the latency of data stores to determine when to actually enforce this prioritization. And when poor performance is detected, storage I/O control will be engaged and will start to throttle back the less important virtual machines. We can also use something called the storage I/O control I/O injector to figure out basically just how fast the data store can possibly be so that we can more intelligently define some of these thresholds as to when storage I/O control should be invoked. And storage I/O control is supported on Fiber Channel, iSCSI, and NFS storage. It is not supported on virtual SAN. So let's take a look at how storage I/O control works from a high level. Storage I/O control is simply shares, limits, and reservations. It's simply those resource controls, like we've seen in our lessons on resource pools, but for storage bandwidth. Right? So if we have a situation where storage contention arises, we're going to pick and choose certain virtual machines to prioritize. Like for example, here we've got this ESXi host on the left, and the ESXi host is connected to a data store on, let's say, a fiber channel storage array. Right? And we know that the maximum amount of IOPS that could get pushed to this data store at any time is 3,000. Right? Well, we can also just simply identify, a latency threshold. So we could say, hey, if latency exceeds 20 milliseconds, start kicking into storage I/O control. Right? And here's what's going to happen, right? We've got these two VMs, and both of these VMs have their virtual disks located on this data store. VM1 has 500 shares. VM2 has 1,000 shares. Basically meaning that if a contention problem arises, VM1 is going to get half the storage bandwidth that VM2 is. So essentially VM1 can only push half the IOPS that VM2 can. Now the beauty of shares is under normal operating circumstances, this is actually not enforced. Shares are only enforced if a certain latency threshold is met. Right? So when we start to get contention, that's when this share structure actually gets enforced. And hopefully the real goal here is to avoid this latency altogether and avoid this contention altogether by properly load balancing our data stores and by purchasing storage devices that can handle the required workload. Right? So we could load balance our data stores using storage DRS that we learned about in the last video. And storage I/O control and storage DRS are definitely complementary solutions. Right? I kind of think of it this way. Storage I/O control is like aspirin. Right? When you get a headache, you can take aspirin and it's going to make you feel a little bit better, but it's not actually attacking, the root cause of your headache. If you could potentially, change whatever's giving you a headache and get rid of that, that's kind of like storage DRS, right? That's preventing the problem before it occurs. Right? So what storage DRS is going to do is it's going to monitor latency across a cluster of data stores. And if latency starts to get too high, it'll use storage vMotion to start moving virtual machines around from one data store to another. Right? And by balancing out that workload, hopefully we don't even need to invoke storage I/O control. Hopefully the latency can be avoided altogether. Okay, so in review, Storage I/O control is used to prioritize storage commands over our network. We can configure shares, limits, and reservations, and it's only enforced when poor performance is detected, or we can use the I/O injector to determine the maximum throughput of a data store. Storage I/O control is supported on Fiber Channel, iSCSI, and NFS storage. And ideally, we can prevent the problem altogether by properly balancing our data stores. And a good way to automatically do that is to create a data store cluster and configure storage DRS.